Welcome back to our second session, simultaneous equations. Today we're going to cover using the method of substitution to solve simultaneous equation. Before we do that, let's do a quick review of some of the concepts that we learned a long time ago that's going to help us today. So if I have x plus 2 is equal to 20, and I want to solve that, I want x on a side by itself. So I'm going to transpose this 2. It's positive on this side. So when I take it over, which is transposing it, it's going to become negative. So I'm going to have x is equal to 20 minus 2, hence x is equal to 18. Now, if I have 2x plus 3 is equal to 17, the first thing I'm going to do is I'm going to get rid of this plus 3. It's in my way. I want x on the side by itself. And so I'm going to transpose that. And so I'm going to have 2x is equal to 17 minus 3. It becomes minus. Hence 2x is equal to 14. And then to find x, I got to divide both sides by 2. So x is going to be equal to 14 divided by 2. X is equal to 7. Now, what if I had x divided by 2 plus 2 is equal to 14? Again, before I take a look at the part that has x in it, I got to get rid of this. This is clearly my first move, so I got to transpose that. So when I transpose that, I'm going to have x divided by 2 is equal to 14 minus 2. And so x divided by 2 is going to be equal to 12. Now, I have a fraction here. And I got to get rid of that 2 in the denominator. This 2 right here, I got to get rid of, right? I don't want that there because all I want is x. But I realize that if I multiply this by 2, if I do that, and this cancels with this, and indeed I'm left with just my x that I'm looking for. But if I do that on one side, I've got to do it on the other side. And so 12 times 2 becomes 24, which makes sense because 24 over 2 should in fact give me 12. So that's correct. What I want you to see here is this was a fraction and I didn't get scared. I didn't get timid. I knew what to do. I got rid of the fraction. No big deal, right? No big deal. So let's take a look at another problem. What if I had x plus 2 divided by 4 is equal to 8? All right. Again, I can't do anything with this 2 because this is a part of a whole. This is one term, but this is a fraction. So I got to get rid of this fraction. And the only way to do that is to multiply it by whatever the denominator is. But then I got to do it on the other side as well. So now here, these will cancel out. So this will simply become x plus 2. And here, this will become 32. Now I could do something with this 2 because they're separate terms now. They're not one term. And what I have to do is transpose it. So now x becomes 32 minus 2. Hence, x becomes 30. Okay, so let's take a look at something else. What if I said to you, make x the subject of the equation? Now, this is your instruction. All right, so here's your problem. You have x plus 2y is equal to 10. Now you have two variables here, but I want x to be the subject of the equation, which means forget 2y. Let's not treat it as a variable. Let's treat it as just something else that's in the way because I want x to be the subject of the equation. That means I got to take this 2y and transpose it just as I would any other constant. If I do, it becomes negative. So x then is equal to 10 minus 2y. Another way that I could have said that to you is I could have said, write x in terms of y. So you have two variables, you're going to write one in terms of the other. That's the same thing as saying making the first one the subject of the equation. What if I gave you the same problem? It says x plus 2y is equal to 10. And I say write y in terms of x. That means make y the subject of the equation. Now, what does that mean? That means x has to be treated as something that we don't want on the same side with y. So I got to transpose this x. I'm going to have 2y is equal to 10 minus x. See, this was positive over here, so now it becomes negative. But I'm not finished. Now I got to divide both sides by 2. So now this side, after divided by 2, they cancel out, so it becomes just y. And this becomes 10 minus x divided by 2. Not just x divided by 2, not just 10 divided by 2, 10 minus x. Whatever is on this side has to be divided by 2. And now I have written y in terms of x. How is that helpful? Well, let's try our hands on this, right? So we have a simultaneous equation here, and we need to solve this by the method of substitution. So what I have here is I'm going to call this equation 1, and I'm going to call this equation 2. This is just so I can make reference to them. And because I want to be very careful and let my teacher know what I'm doing, I'm going to be very clear with the steps I'm taking. Particularly because this is your first problem like this, I want you to write these steps down. So I'm going to say from equation 1. And I'm going to write out equation 1. Actually, let's do equation 2. I'm going to say from equation 2. I'm going to write out equation 2. It says x minus 3y is equal to minus 8. Now, I'm going to write this at x in terms of y because it's easier. So I'm going to say, we're going to transpose this minus 3y. So I'm going to say x is equal to 3y minus 8. See, it was negative here, now it becomes positive. Now, what am I going to do? I'm going to substitute x is equal to 3y minus 8. Notice I'm writing out what I'm doing. I'm very clear at what I'm doing every step of the way so I can follow my work when I review it. So my teacher can see what I'm doing. And I'm going to put that into equation 1. Why equation 1? Because I got it from equation 2. So I can't resubstitute it right back into equation 2. I'm going to write equation 1 in its entirety, okay? Its original form. So it was 3x plus 2y is equal to 9. So wherever I see x now, wherever I see x, I'm going to be putting 3y minus 8, right? So I have 3, and instead of x, I'm going to put 3y minus 8, right? That's just this right here. Plus 2y is equal to 9. So let's do some math here. I got to work out what's inside the bracket first. So 3 multiplied by everything in here. 3 times 3y is 9y. 3 times minus 8 is minus 24. And then I have another 2y here. Okay? So what I'm going to do now is I'm going to put together this and this because they're like terms. They're both y's. And I'm going to transpose this and take it over here because it's not y. And I'm going to solve for y. So I want only y on a side by itself. All right? So I'm going to have 9y plus 2y is 11y is equal to 9 plus 24. Y plus 24, I transposed it. And what's 9 plus 24? It's 33, right? So 11y is equal to 33. You divide both sides by 11 to get rid of this 11 here. And have y is equal to 33 divided by 11, which is equal to 3. Hence, y is equal to 3. Now take a look at what I did here. I went from a multivariable equation, this one right here, 2 variables. This one is also 2 variables. And because I was able to, catch the word, substitute for x in terms of y, I was able to end up with a single variable equation, 1 variable. Now I have found y. Remember the concept of simultaneous equation. Y has to be the same in both. Whatever y is, x has to be the same in both, whatever x is, right? So now that I have y, I can now come and I can substitute into any of these equations. Y is equal to 3. And I'm going to choose equation 2, but I don't have to. I could choose anyone at this point. I'm just going to choose equation 2 because it seems easier. So x, I'm write it out in its initial form, right? Now, wherever I see y, I'll put 3. So x minus 3 times y, which is 3, is equal to minus 8. Again, now I have 1 variable. So this is x minus 9 is equal to 8. So I've got to transpose this minus 9. I've got to transpose this minus 9. This is minus 8. So now I have x is equal to minus 8 plus 9. Hence, x is equal to 1. So x is equal to 1 and y is equal to 3 are the solutions for this problem, right? These are the solution to this problem. Now, remember, I taught you how to check this, right? So let's look at the first one. Let's see if we can check it in the first one. If this is 3 times x, and we're saying x is 1, so 3 times 1 is what? 3. Plus 2 times, what is y? We said y is 3. 2 times 3 is 6. Does that in fact give us 9? Yeah, it does. It checks out. And you do the same thing over here, and it's going to check out. So we could double check our answers just like so. Right? Just like that, we can double check our answers. Now, what we want to do now is we want to do the same problem, but this time we want to substitute for y. Okay, we substituted x for x, and I want to substitute for y. So let's take a look at that. So let's write this problem over. All right, so I have 3x plus 2y is equal to 9. And then I have x minus 3y is equal to minus 8. Remember, this is equation 1 up here, and this is equation 2 down here. This is just for our reference, right? Right. So now what we could do is we could go to any of these two. Again, I'm just going to go from equation 2. But we're going to do something different now. So from equation 2, and I write out equation 2, right? Says x minus 3y is equal to minus 8. Now, from this, I can see that minus 3y is equal to minus 8 minus x. See that? So x now got transposed. So it becomes negative. And I'm going to divide both sides by minus 3. So now I'm going to find y. So y is equal to minus 8 minus x divided by minus 3. So wherever I see y, I can substitute this, right? Now we could rewrite this if we want to in a different way. So for argument's sake, minus 8 minus x is the same thing as minus 8 plus x, which is the same thing as minus x plus 8. Because if you put the minus into both of them, you get minus 1. This is a invisible 1. Minus 1 times x minus 1 times 8, which is minus 8 minus x. So that's on top, right? So this then becomes minus x plus 8 divided by minus 3. And so this is really and truly just x plus 8 divided by 3, because a minus divided by a minus, they cancel each other out. So we're going to substitute x plus 8. Actually, we're going to say y is equal to x plus 8 divided by 3 into equation 1. We got it from equation 2, and so we're going to do it, substitute it into equation 1 now, all right? So what does equation 1 say? It says 3x plus 2y is equal to 9. Let's use a different color here. So wherever I see y, I'm going to put this right here, right? So I have 3x plus 2, x plus 8 divided by 3 is equal to 9. Now, let's not get scared here. This is a fraction. That's all this is. All this is just a fraction. Okay? So, because this is a fraction, let me make some more space here. Because this is a fraction, I'm going to have to do something to get rid of the fraction, and I want to do it right away. But before I do it, recognize that there's no more y. See that? Y is gone. There's no y. I'm already down to a single variable equation. Now, what I have to do here is I have to multiply by 3 to get rid of this. But I have to multiply by 3 on both sides. Which means if this is here, I got to multiply this by 3. Then I got to multiply this by 3. I know what's going to happen when I multiply this by 3, because that's the reason I'm choosing 3, to get rid of this. So 3 times 3x is 9x. And when I multiply this by 3, the 3 cancel out, so I'm going to be left with 2x plus 8. And this is going to be 9 times 3 is 27. So this becomes 9x plus 2x. Okay, notice what happens here. 2 times x plus 2 times 8. What's 2 times 8? 16 is equal to 27. Hence, I have 11x plus 16 is equal to 27. 11x is equal to 27 minus 16. I transpose it. So 11x is equal to 11. Hence, x is equal to 1. X is equal to 1. All right. And what we're going to do now is we're going to substitute x is equal to 1 into equation 2. We're going to write out equation 2 in its original form, which is x minus 3y is equal to minus 8. Wherever we see x, I'm going to put 1. So now this becomes 1 minus 3y is equal to minus 8. So minus 3y is equal to minus 8 minus 1. See, this one was positive here, so I got to transpose it. So I have minus 3y is equal to minus 9. Now I got to divide both sides by minus 3. So I get y here, because when I do minus 3 divided by minus 2, they cancel out, is equal to minus 9 over minus 3. Hence y is equal to 3. So I get the same answers. This one appears to be more work, which is why I went the other way first, but we'll get the same answer, okay? We get the same answer. All right? So, having said that, let's give you one to work on. Let's give you one to work on. And let's say we had 5x plus 4y is equal to 10.5. And let's say 4x plus 3y was equal to 8. So this is equation 1 and equation 2. All right. Now, what I'm going to do for you is I'm going to tell you what I want you to do first. I want you to use equation 2 and write x in terms of y. Use equation 2 and write x in terms of y. So you're going to start something like this. From equation 2, you write out equation 2 for x plus 3y is equal to 8, right? You're going to write x in terms of y, all right? So what I'm going to do is I'm going to give you some time to do that. So again, this video at this point needs to be paused. Give you about 7 minutes to 10 minutes to do that. And you come back, unpause it, and then I will work it for you. All right, so let's pretend that time has passed. All right, I want to write x in terms of y, which means I'm going to take the y over. So I'm going to have 4x is equal to 8 minus 3y. And so x is equal to 8 minus 3y divided by 4. So I have written x in terms of y. Right? So what I'm going to do now is I'm going to substitute x is equal to 8 minus 3y divided by 4. And I'm going to put that into equation 1. So I'm going to write out equation 1, 5x plus 4y is equal to 10.5. Now, wherever I see x, I'm going to put 8 minus 3y divided by 4. So this is 5 times x, right? So x is 8 minus 3y divided by 4. Then plus 4y is equal to 10.5. At this point, I have no x's in here, but I have a fraction. And I got to get rid of this fraction. And before we get tantalized by this fraction, we're just going to multiply it by 4. But we're going to multiply everything on this side of the equation by 4 and the same over here. And the reason for that is simply to get rid of this, right? So when I get rid of this one, I'm going to be left with 5, 8 minus 3y plus, and remember this 4 has to be multiplied by this as well. This becomes 16y, and this becomes 42. So 5 times 8 is 40. 5 times minus 3 is minus 15. Plus 16y is equal to 42. So now let's look at the, first of all, let's transpose this 40. This is positive here, over here is going to become negative. So this is 42 minus 40 and minus 16y plus 16y gives us just y. Hence y is equal to 42 minus 40, which is 2. Now, we're going to substitute. Y is equal to 2 into any of these equations up here, right? So let's choose equation 2. And it doesn't matter which one you choose. It really doesn't. Let's write it out in its original form, which is 4x plus 3y is equal to 8. So wherever I see y, I'm going to put 2. So I have 4x plus 3 times y, but y is 2, is equal to 8. So 4x plus 6 is equal to 8. So I'm going to take the 6 over, and there's a name for that. That's right, transpose. So I have 4x is equal to 8 minus 6, which is 2. I got to divide both sides by 4. So I have x is equal to 2 over 4. Hence x is equal to 1/2. And so these are the solutions to this problem using the method of substitution. All right. So now, this is your assignment. Now, in terms of the first assignment, what you should have done is you should have found a way to get that response to me, and I would have given you back feedback on that. Same thing goes here. All right. So at any point in time, find a way to get in touch with me, and I'll demonstrate to you how to do that. Or I'll create some videos with the solutions, but I don't want to do it during the class time. If you have questions, we could go over that. So if this was a live class, then we would take some time at the beginning of class to go over the assignment. Okay. So what you want to do is you want to either find a way to get some live classes, or simply take advantage of the other mechanisms that we have, such as the email. Drop a comment. If you're watching this on YouTube, you can drop a comment there. If you're watching it to a live pre-recorded session, ask the facilitator to find a way to get a question to me, but my email address is also right there. Go for it. All right. And that's where we will stop for this session.